Hello everyone, my name is Mehak Soni and I'm going to explain on the topic polygon, types of polygon and polygon clipping. So before starting, let's take an overview. We are going to discuss polygon, types of polygon, clipping, polygon clipping. All these topics we will going to cover in this presentation. Polygon. What is polygon? So polygon is nothing but a closed figure end-to-end connected made up of more than two line segments on a two-dimensional plane. The word polygon is made up of two words. First, poly means many and gons means sides. Polygon means nothing but a shape having many sides. Here, four polygons are given: the square, triangle, pentagon, and hexagon. Now, what are the types of polygons? So, there are four types of polygon. First one, regular polygon. What is regular polygon? So, if all the sides and the interior angles of the polygon are equal, or if a polygon is equiangular or and equilateral, then the polygon will be known as regular polygon. So, example for regular polygons are square, rhombus, equilateral. Here all the sides are equal and interior angles are also equal. Now, irregular polygon. If all the sides and the interior angles of the polygon are of different measures, then the polygon will be known as irregular polygon. There are some examples of irregular polygon, such as here it is shown rectangle and kite. Scalene triangle is also a irregular polygon. Now third one is convex polygon. If all the interior angles of the polygon are strictly lesser than 180 degree, all the interior angles means inside the polygon, the angles are if angles are lesser than 180 degree, or if a line segment between 2 points on the boundary does not go outside the polygon, then the polygon will be known as convex polygon. Here two figures are shown. We can see that the angles of every corner of the vertex is lesser than 180 degree. Now, what are concave polygon? If one or more interior angles of the polygon are more than 180 degree, or a polygon contains at least one reflex interior angle, then the polygon will be known as concave polygon, and this polygon can have at least four sides. So here in this figure, it is seen that some angles inside polygon is greater than 180 degree. So it represents a concave polygon. Now we have discussed all the four types of the polygons. Now we will move to clipping. What is clipping? So in computer graphics, our screen act as a 2D coordinate system. It is not necessary that each and every point can be viewed on our viewing plane. We can have viewpoints in a particular range, that is from 0, 0 and x maximum, y maximum. So clipping is a procedure that identifies those portions of the picture that are either inside or outside of our viewing plane. So clipping is nothing but the portion which is inside, either inside or outside of the viewing plane. We identify those planes, those viewing planes. So it is basically clipping only. A necessary part of the viewing plane, we remove it, and which is the necessary part, we accept that part, and we display that part. For deciding the visible and invisible portion, a particular process called clipping is used. Clipping determines each element into visible and invisible portion. the visible portion is selected and invisible portion is discarded, as I have told earlier. Now, uh, these are two figures. First one shows the original picture, which is before clipping. So here we can see that the lines which are inside the, which are on the rectangle or inside, this is square. So the lines which are inside or on the square or completely outside shows the picture before clipping, and after removing the outside lines we get the picture which shows after clipping picture. Now, types of lines. So visible, invisible and clipped line. Then there are three types of lines we will discuss here. Visible, a line or lines entirely inside the window is considered visible. The lines which lie inside the window is considered as visible. Invisible lines are those lines which are outside the window and they are considered as invisible. Clipped means what? A line partially inside the window and partially outside is clipped. Okay, so for a clipping, point of intersection of the line with the window is determined. We need to determine the point of intersection of the line with the window so that we can clip the outside part of the line to get the visible portion. So here it is shown. Case 1, visible lines means all the lines are inside the window, that is visible. This shows visible part. And clip in case 2, all the lines are outside the window means they are invisible. In third case, lines are on the window boundaries, so we need to determine the intersection point, and we need to remove the um, part which lies outside the window boundary. So in case 4, it is seen that some part of the line are outside, some part of the lines are inside, some part of the lines are on the window side, window edge. So we need to we need to first remove the invisible part. We need to accept the visible part, and we need to find the intersection of the line which cuts the window boundary. So this represents the mixed lines. Figure 4 represents mixed lines. Now, area clipping, which is also known as polygon. So there are various methods of clipping, various algorithms of clipping. So here we will discuss about the polygon clipping. So Sutherland Hodgman polygon clipping. This is the polygon clipping algorithm. So here we will discuss what this algorithm tells. It is performed by processing the boundary of the polygon against each window corners or edge. First of all, entire polygon is clipped against one edge. We need to clip the entire polygon against one edge. Then the resulting polygon is considered. Then what we need to do, the resulting polygon is taken as an input, and other edges which are outside the polygon, we need to remove that. And from all the four sides of the polygon, we need to do the same thing to get the visible part of the line. So there are four possible situations while processing. If the first vertex is an outside the window, the second vertex is inside the window. The second vertex is added to the output list. The output of the intersection of the window boundary and the polygon side or edge is also added to the output line. So basically, these are the rules which we will cover in next upcoming slides. But here we need to see in theory that if both vertices are inside window boundary, then only second vertex is added to the output list. If both if the first vertex is inside the window and second vertex is outside the window, then uh, the edge which intersects the window is added to the output list. If both vertices are the outside window, then nothing is added to the output list. So I think this is not very much clear. We will discuss it now so that it will be clear to everyone. So this is the figure. Here what is seen that um, a polygon with one side v1 and v2, and we need to consider only the only part of it which is inside the window. So we need firstly, if our point lies from outside to inside, then we need to consider only the intersection point of v1 and v2 along on the window edge. So we have considered v1 dash to v2. From outside to inside, we will save point v1 dash to v2. In second picture, it is shown that v1 and v2 are inside the window. So we don't need to take v1. We need to take only v2 point. Now in third picture, if we are going from inside to outside, then we don't need to save the point which is inside or outside. We need to save the point which is on the which is the intersecting point of v1 and v2 on the window's edge. So that is v1 dash. Now in fourth figure, what we need to do is that if our point lies outside the window, means v1 and v2 lies outside the window, so we don't need to save points. None of the points will be saved in this figure. So by looking at this all the things, what we get that we are considering the part which are inside the window only, and we are removing the part which lies outside the window. So this is basically Sutherland method algorithm specify or says. So as per we have discussed above, now this is the shortcut which I have written, and these are the we can say these are the rules for this method, this algorithm. First one, outside to inside, save point v1 dash to v2. Then if points lies inside the window, then save v2 point. If point lies from if line edge is directing from inside to outside, then save the point which is the intersecting point of the line to the window. And outside, if edge is outside to outside, then we no need to save any point. We have done with all this. So by doing all these rules, by following all these rules, we will get the polygon area which lies inside the window. So this is basically Sutherland's algorithm. In this picture, it is very clearly seen that we have the input polygon. So we need to clip the point which are outside the window. So after clipping the polygon, we get the output polygon as shown here. So firstly, what we have done, we have fixed the one edge and we have removed all the points which lies outside the window, outside the right side of the window. Then what we have done, uh, we have selected the bottom of the window line, and we just remove the points which lies outside the window of the bottom line. And after doing this, we select other next left window side, then top window side. So by doing all this process, by doing all this by doing this thing with all these four edges, we get the output polygon. So this is basically Sutherland's algorithm. Thank you.